Hello all, welcome to Code Hub. Today let us solve the third weekly contest problem, which is nothing but minimum score of the path between two cities. So before moving into this problem solution, I will request you to solve the problem by yourself. So you are given a positive integer n representing n cities numbered from 1 to n. You are also given a 2D array roads where roads of I as AI BI distance of I indicates that there is a bidirectional road between cities AI and BI with a distance equal to distance of I. So the cities graph is not necessarily be connected. So it is not necessarily be connected. So the score of the path between two cities is defined as the minimum distance of a road in this path. So what does that score mean? Score of a path between two cities is defined as the minimum distance of a road in this path. So return the minimum possible score of a path between cities 1 and n. What to be noted here is a path is a sequence of roads between two cities. It is allowed for a path to contain the same road multiple times. So if we take one path, it is not necessary that we should not take that path multiple times. So and you can visit cities 1 and n multiple times along the path. So the test cases are generated such that there is at least one path between 1 and n. So since there is at least one path between 1 and n, we have to calculate the minimum score. So for this graph, the minimum score is 5. But how is it 5? So the path is 1 to 4. But why do they take this 1, 2 and 4? Because we can go with any road that, such that that is connected with 1 and that is going to reach obviously n. So we can take every path that is connected to 1. So that is our first observation. So by observing that, what we necessarily do here is we can go to 1 to 2, then 2 to 4, and such a way that we can have a minimum score 5. So that is our output. So let us see in this example. In this example, you can see that 1 to 3, 3 to 4, that is the path, but the output is 2 because we can go from first 1 to 2, then we can return, then our score becomes 2 now. Then we can go to from 2 to 1, then we can go to the go in the path 1 to 3, then to 3 to 4. So by this path we encountered 2 as the minimum score, and that is our output. So we can encounter a road multiple times. That is what the problem. So with our observation, what we can just say is, so the path that is connected to 1, every path we can just do a DFS, and we can just score the we can just store the minimum value that is connected to 1. Obviously we have provided that we know that there is one, at least one path that connects 1 to n. So we can just take the minimum score of a path which is connected to 1, and we can just return the minimum score. We can just return the minimum distance that we encounter in this path. So what we can do is we can do a DFS. So 1 is connected with 4, then 1 is connected with 2, then 2 to 3. We can just do a DFS and then 2 to 4, and we can just store the minimum distance, which is 5. Similarly, for the example 2, we can go from 1 to 3, then 3 to 4, the minimum is 4, and then we can go from 1 to 2, the minimum is 2. So the total minimum distance that we have encountered in this exploring the paths from 1 is nothing but 2, and we can just return them. So what we can do is we can just form a graph here. This is how we can create a graph. So x and y is a road, and d is the distance, and we have a graph that is connected bidirectionally, and I have declared an answer globally, which is going to store me the minimum score. So initially it is initialized with int max, and I have a vector which is visited, and I am doing a DFS starting from the node 1. So while doing DFS, if it is already visited, we just return. If it is not visited, we just do visited of u to be true. Once it is visited, what we do is we can run a for loop, and we can go for its adjacents, and we can just store the minimum distance in our answer. Answer is equal to minimum of answer comma adjacent dot first. So dot adjacent, the first in my pair value is going to be our distance. and I'm calling the next DFS call with their adjacent nodes. So by this, I'm storing the minimum values, minimum score, and finally I'm returning the answer. So this is also passing all the test cases. Hope you like this solution. Let us see in the next weekly contest. Until then, keep up solving.